Good day, good day, good day, folks. Good day, folks. Good day, folks. I hope you are doing very well. I'm very excited today to look upon another section of Technical Mathematics, Paper 1, uh, Department of Basic Education / November 2022. Then we are going to embark on question number 2. Question number 2 is whereby we are going to indulge the nature of roots. Before we tackle the questions that we have here as far as this question number 2 is concerned, let me briefly give an understanding. Let me outline the dynamics so that our learners have a full understanding of what is required of themselves as far as question number 2 is concerned. Briefly, let us go to question number 1. Question number 1 of technical mathematics is whereby learners are expected to solve for the solutions, to solve for the values of x. That is question number 1. So whereby we use the usage of factorization, we apply the quadratic formula there so that we are able to attain those solutions of what? Of x. Now, if we go to question number 2, please candidates, please learners, particularly those who are doing grade 12, in question number 2, refrain from solving for x. In question number 2, you are not required to solve for x there. Because why? Already in question number 1, you have solved for x. You can't repeat solving for x again. In question number 2, remember, is whereby you are going to deal with the nature of roots. Is whereby we must utilize the concept of the discriminant. Now, what is the nature of roots? Nature of roots, it is a very interesting topic for one to embark upon and to look upon. Nature of roots is the topic that gives us an understanding, that gives us the glimpse of what kind of roots, what kind of solutions of x that we can get without actually solving for x. Meaning that the nature of roots, it gives us the understanding, it gives us the idea, it gives us the glimpse to say if we have to solve for x, what kind of roots that we can expect without actually solving for what? For x. In this case, we are not solving for x, but the nature of roots, it says if you have to solve for x, these are the kind of roots that one have to what? Expect. And I want to repeat and put it forward. Please, candidates, question number 2, don't apply quadratic formula or factorization. In question number 2, you are required to use the concept of nature of roots. You are required to use the concept of the discriminant so that you are able to describe the kind of solutions of x that we can actually expect using the value of what? The discriminant. I think I was emphatic around what is required in question number 2. Then let us dwell into the question number 2 that we have here. 2.1, it says given the equation x squared minus 2x plus positive 6, that is said to be equal to 0. The question that we are going to do, it is question number 2. Question number 2 of November 2022. Now, let us address different questions that we have. 2.1.1. In 2.1.1, what are we required to do? It says determine the numerical value. Determine the value of the discriminant of this quadratic equation that has been given to us. Mark allocation there, 2 marks there. Then, remember, for us to find the numerical value, there is a formula that we can utilize to find the numerical value of the discriminant. What is the formula? The formula says, let us go and write the formula. The formula says delta, which is a triangle like, but in this case, under question number 2, this is not a triangle. That is discriminant. That is what? Delta. Delta is equal to b squared minus 4ac. That is the overview topic of what? Overview equation of the discriminant. It says delta is equal to b squared minus 4ac. And from the quadratic formula, we know that the value of b, we can get it from the quadratic equation. The value of a, we can get it from the quadratic equation. And the value of c, we can get it from the quadratic equation. And in this case, here we are given the quadratic equation. Then you must use this quadratic equation to substitute the value of b where you see b, substitute the value of a where you see a, and substitute the value of c where you see c. Then remember, let me emphasize, the value of b that you see here is any number and its sign, any number before an x term. Then you go to this quadratic equation, you check the x, any number, the coefficient of x and its sign. That is going to be the value of b. Then the value of a is any number with its sign, any number before an x square term. In this case, we are saying the coefficient of x squared term. Then c is that constant number without an x. Then let us go and substitute. Is equal to square, because it says b squared. Then we have our brackets here to substitute. Remember, when you substitute, you introduce bracket. Then when we come here, when we check, here it's our x. Here it's our x. Then this number before an x here, that is going to be the value of what? Of b. Where we see b, substitute this value, in this case is negative 2. All square. Then we go on to substitute minus 4. Remember, every time when you substitute, open bracket, the value of a from here, we check the x squared term. Now we see that there is a number that is silent here that has been given to us. Remember, mathematically 1 is silent, meaning the value of a will be 1, that is silent. And lastly, we must substitute the value of c. A c is any number without an x. We call it the constant number. Then the number without an x is only this one here. It means this positive 6 here, it represents the value of c. Substitute the value of c where we see c. Now we have correctly substituted into the formula of what? The discriminant. Value of b, negative 2. Value of a, 1. And the value of c, positive 6. Now, what is going to happen after this step? We are going to utilize our calculator to find the value of the discriminant. Then delta is equal to, then what is the value of delta? I'm just going to use my calculator. Negative 2, close bracket, square, minus 4, open bracket, 1, close bracket, open bracket, 6, close bracket, equals to. It says from the calculator the value of delta, or we must first say therefore, because that is the conclusion. We must conclude to say therefore delta is equal to negative 20. That is the value of delta. Delta is equal to negative 20. How do we mark here? 1 mark for correct substitution into the correct formula. 1 mark for the value of delta. That's why mark allocation there is 2 marks. We go on 2.1.2. This is how you approach 2.1.1. Now, 2.1.2, it says hence. Candidates, remember, if the question says hence, it says use the answer that you have from your previous question. In this case, it says use the value of the discriminant, the numerical value of the discriminant. Use that answer to describe to us what kind of roots we can expect. Describe the nature of roots of the equation. What equation is that? The equation that we have here. Now, since the value of delta that we have here is a negative number. Remember, if the value of delta is any negative number, it doesn't matter how large, how small it is. If the value of delta, it has a negative sign, it means the roots are going to be they're going to be non-real roots. What does that mean? It means if we have to solve for x for this equation, the roots of that equation, of this equation, are not going to exist. Non-real roots, it means the roots, the solutions of x are not going to be there. The other word that we can use is the word imaginary roots. Please don't use both of them. It's either you are going to use the word non-real roots or imaginary roots. This is an indication that if we have to solve for x here, if we have to apply the quadratic formula here, the roots, the solution of x are not going to be there. We are not going to get the values of x. That's why we are saying the roots are not going to exist. That is the indication of non-real roots. We go on 2.2. That is that 1 mark there for the words or the word non-real roots or imaginary. Then in 2.2 it says determine the numerical value of k for which the equation x squared plus 2x plus k is equal to 0 will have real roots. Before I emphasize or before I embark on this question, please, candidates, don't say k here it's 6, because now these two are, they are not the same. There's a minus, there's a plus. Sorry. Let us go on. The question says to us, we are required to find the numerical value of k if the roots of this equation are going to be real roots. Then the word real roots, it says if the roots of this equation are going to exist, it means the solutions of x are going to be there. We are required to solve for what? For k. Remember, the word real roots is the condition for the nature of roots. Then we are going to use this condition of real roots to help us to find what? The numerical value of k. Then we need to ask ourselves a relevant question to say, for us to have real roots, what needs to happen to delta? Now, by now your teachers across different provinces should have given you all those descriptors, all those conditions for the nature of roots, so that you know if the examiner says real roots, what needs to happen to delta. And by now we know for us to have real roots, it means delta, which is the discriminant, it must be greater than or equal to 0. For us to have real roots, delta, it must be greater than or equal to 0. This is a condition. We are taking these words, real roots, and we are writing that in an equation to say, for us to have real roots, delta, it must be greater than or equal to 0. Then what is delta? From this equation here, we understand that delta, it is equal to b squared minus 4ac. Where we see delta here, we are going to write what is equal to delta. Then let us do that to say delta is equal to b squared b squared minus 4ac. That should be also greater than or equal to 0. Then from there, we are going to use this equation that we have here. Substitute. Remember, b is any number before an x. It's a coefficient of an x. A is any number before an x squared term. And c is anything here without an x. We call it the constant. Now let us substitute using that equation. Remember, it is b squared. We must start with the square. Square here. Now we are substituting. We must introduce brackets. Then when we come here, we check. Here is an x. The coefficient of x here is a positive 2. Then where we see b, we write the 2. Then we go on with the substitution. Minus 4. Then we must substitute the value of a. We go to an x squared. We see that there is a 1 that is silent there. That is not retained, but it's there. It means in this case, the value of a will be 1. And lastly, the value of c. And now the constant, what do we have here without an x? We have an x squared term that can be c. We have an x that can be c. Then anything without an x here is k. Meaning that the k in this case, it represents the c. Where we see c, we are going to write the k. That must be greater than or equal to 0. Now we go on. From there, we need to what? Simplify. We must simplify what we have here. Let us simplify. Then we know that 2 squared, it results to 4. Minus, then remember mathematical bracket means multiply. Then 4 multiplied by 1, it's a 4. Then 4 multiplied by k, it results to 4k. That should also be greater than or equal to 0. Then remember, the value of k that we are looking for, it should be a positive k. Now, since we are having a negative 4k here, we are going to transpose this negative 4k to this side. Transpose this negative 4k to this side. So that 4k, it becomes what? Positive. Meaning that on the left-hand side of the equation, we'll be left with a positive 4. Then that is going to give us 4 greater than or equal to positive 4k. Now remember, we are only looking for k. We are going to divide by this 4 before the k, this side on the right and this side on the left. Then that is going to give us the value of k to be 1. Not 1 isn't equal to 1, no. Then we have 1, our inequality sign, then k. In this case, k, it must be less than or equal to positive 1. That is the values of k that is going to give us what? The roots that are real. K, it must be less than or equal to 1. Mark allocation there, 3. How do we mark? 1 mark for delta, it must be greater than or equal to 0. 1 mark for correct substitution into the correct formula. And 1 mark for k, it must be less than or equal to 1. 3 marks there. Then this is an overview of this question. Mark allocation, total mark there, 6 marks there. Then for this question number 2, November 2022, mark allocation there was 6 marks there, given for Mahala there. Thank you so much. We are going to see each other on the next video that I'm going to also upload. Thank you so much.